Today is Saturday, September 10th, 2022. It is also day 419 of data science, and today I have this lesson from Stats Medic. Um, it's literally just a lesson from an AP stat class that you would just give in high school, and it's really about predictions and using the least squared regression line and finding the least squared regression line. And instead of using the calculator, I'm just going to go through this and do it with Python. So the first thing it says here's the data from one of the groups. The group forgot to record their measurement for 5 rubber bands. And so the data is just the number of rubber bands and then the distance traveled by the Barbie doll. So I'll actually have to transfer this data to Python. So I'll import pandas as PD. And again, pandas is just a data analytical library that you can use to create data frames, to even, analyze data, wrangle it, and just do what you want to do with the data. So in this case, I'm going to create a variable called df that stands for data frame, and I'm going to use pd.dataframe. So data frame is the function, and it creates a data frame. And so the first thing you would want to pass is a dictionary, and so a dictionary has a key and value. So the key would be, in this case, the column name, so that would be the number of rubber bands, and then the value would be a list of the values. So that would be 0, 1, 2, 3, 4, 5, 6, and 7. And then you would do comma and you put in another key again. So this would be the distance traveled. And then that would be in centimeters. And then you would do comma and put in the values, which would be 25, let's see, 32, 41, 49, 55. And then in this case, well, this would be a problem because now it doesn't have a value. So I'm just going to say none for now. 69 and 78. Let me run that and see what that gives me. Let me just go here and click on DF. All right, so now I have the number of rubber bands and I have the distance traveled. So here's my data, basically this little bar over here. It's in Python now. And I just put none so that, it gives me a null value for 5 because that is the value, we're trying to predict. So the goal right here, or at this moment, is to predict the distance traveled by the Barbie doll who has, 5 number of rubber bands, because the group who was performing this experiment actually forgot to measure that specific um, condition, when a Barbie has 5 rubber bands. So they forgot that. So that's the goal for today. And let me just go, and the first thing it says is to go to Statlet.com to make a scatter plot. So I'm not going to go to Statlet.com. I'm just going to go here and do everything in Python. So I'll import Seaborn as SNS, which is a data visualization library. And with this, I can do SNS.scatterplot and then just plot the points that I want to plot. So I'll plot from the data frame the distance traveled, which actually is my y. So let me go do this. So data frame, what is it? Distance, number of rubber bands, and have that be there, and then separate that by a comma, run that, and then that should give me my scatter plot, which is perfectly linear. So we don't have to do any like transforming of the data, linearizing of the data. Like, it's given to us that it's linear, and because it's linear, we're now able to use the least squared regression line to predict the values. And so what it's doing is saying, it's now saying, then click calculate least squares regression line. So how would I do that in Python? Well, the way to do this is the way to do this in Python would be to import SciPy as sc, and then I'll do sc.stats.linregress, and then I would put in my values. So this would be like my number of rubber bands, and then comma, data frame, distance traveled. And so now if I run that, it's going to return to me the slope and the intercept. Now, I believe the reason why it returns to me nothing is because of this null value here. So what I'll do is I'll just go and get rid of this fifth value, I guess. So I'll go here and delete the fifth value, and then I'll just go back over here and delete this value. And then if I run that, now I have everything without the fifth value. Let's see. Yep, it skips 5. All right, so let me redo this. Okay, and now redo this, and then now I actually get my slope calculated and the intercept also. So let me go to the actual doc now. So essentially, let me make sure this is locked. Okay. So the equation for a least squared regression line actually looks like this. So it's y hat is equal to a plus bx, where a is the y-intercept and b is the slope. So in this case, I'm just going to round to 4 decimal places for the sake of, simplicity. It would be predicted y is equal to the y-intercept, which in this case is 25. I'm just literally going to say 25 right now. And then it would be plus, and then the slope, which would be 7.40. Actually, maybe I shouldn't just say 25. That's probably bad syntax here. Let me do 25.33 plus the slope, which is 20. Oh, it's not 7.46, 38, and then x. And so in context, that would end up being the predicted, what do you call it? The predicted distance traveled is equal to 25.3333 plus, right, 7.4638 x. In this case, x would end up being the number of rubber bands. So again, in other words, it would be y hat is equal to 25.33 repeating plus 7.4638x, if you could even read that. All right, and that's literally all you need for this. And then for number 2, it says use a regression line to predict the distance Barbie travels for 5 rubber bands. Show your work. So all I have to do is just plug in 5 in here. Right? And I'm just going to do that in Python real quick. So what I'll do is I'll actually create the function here. So for here, I'll just call it predicted, let's see, number, or not predicted number, predicted distance traveled is equal to the slope, which I think I could just get from over here. So what I can do is I can just give these things their own values. So I can set slope, and then I could say comma. Let's do y-intercept, comma, r value, comma, p value, comma, whatever that, the standard deviation maybe. And then the intercept of the standard deviation, set that equal to that, and now run it. Not enough values to unpack, expected 6, got 5. What's the other one that I missed? Let me see. Run that. Intercept, blah, 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 this one, this one, this one. 1, 2, 3, 4, 5, 6. What did I miss? 1, 2, 3, 4, 5, 6. I got 6 values. Expected 6 got 5. Oh, let me see. What if I just add a random letter in there? What? Expected 7 got 5? Well, this doesn't make sense. Oh, okay, sure. So then now, I can just get the slope. Let me just really make sure that the slope is what it is. So now if I run that, I should get 7. Okay, perfect. So basically I'm just setting equal, the things that it returned, I'm just setting them equal into here. So this is just like a quick trick that you could do. And then, so I'll do the slope, which would be, well, first of all, it's the y-intercept first. So the y-intercept, and then what's the other thing? The slope, right? And then it would be times x, which in this case, my x is actually going to be the number of rubber bands, right? And I'm actually going to make that a variable up in here. And I'm going to set that equal to be, in this case, 5, right? So I'm going to run that, run this, and then I'm going to copy this real quick. and paste that in here so it actually returns to me that value, which is 62.6522. And so that's my answer. Where's my pen? All right, so it says use the regression line to predict the distance Barbie travels for 5 rubber bands. So the distance Barbie traveled for 5 rubber bands would be 62.6522 centimeters, right? That is the predicted distance traveled, or in this case, y hat. So yeah. And then the next thing, it says one of the group members later found the measurement for 5 rubber bands was 64 centimeters. Was the prediction from number two too high or too low? How far off? So this is where we kind of get the residual involved. So the residual is the difference between your actual value and your predicted value. So just to remember this, I was taught to remember this, that the residual is actually equal to A minus P. So technically AP, since you're in AP stat class, so it's easy to remember. But if you're not in AP stat, I guess, well, you could still remember that. But yeah, so actual minus predicted. So my actual value is 64, right? So it would end up being 64 minus my predicted value, which was 62.6522. And you would just, subtract those numbers and get that answer. And so I'll just do it here in Python, I guess, just to have things formal. So I could do residual is equal to actual minus predicted. And I could actually say predicted distance traveled, and just set that here because that is what my value is. And then my actual value, I'll just set it up here. Actual is equal to, what was it, 64, right? So run that, and then I would say paste that into here, and then run that. And so my residual is 1.3478, right? So in this case, that residual indicates that my predicted value was actually too low, right? Because obviously 64 is higher than 62.65, whatever. Um, so then just kind of like a little thing to remember, if your residual is positive, then that means your predicted value was too low. And if your residual is negative, that means your predicted value was high, right? Because it makes sense that if you have a positive difference, that means that your actual value was bigger and your predicted value was lower. And if you have a negative difference, that means that your actual value was actually smaller than what your predicted value was. So that's kind of just the thing. So the actual answer, it was too low, and it was 1.3478 centimeters off, and that would be my residual. And then, all right, and so number 4 is saying predict the distance that Barbie would travel if the group used 20 rubber bands. Would you trust this prediction more or less than the prediction you made in number 2? So all I have to do is go back to my equation and just plug in 20 instead of 5. So I can go here now and I could just change this value to 20, run that again, and that gives me this value over here. So for me, that ends up being, let's see, 174.6087 centimeters. So that's given, 20 rubber bands. And so now it's asking, would you trust this prediction more or less than the prediction you made in number 2? Well, let's think about it. So if we look at the data, right, our data, the data that we are given, is really only from like 1 to about 10, like 0 to 10, right? So I feel like I would trust, the least squared regression line to give me more accurate values within that range than I would to give me values outside of that range or bigger than like 7 or bigger than 10 when it doesn't even have values to kind of reference to. So the actual answer here is that you would trust what do you call it? The prediction I made in number 2, I would trust that more just because of this term called extrapolation, I think is what it's called. So, like, the idea is you only really want to use the least squared regression line to predict values within the range that your data is in and not kind of, I wouldn't want to predict values of like, like 50 number of rubber bands because there's no data over there. There's no data in so far away. There's only data for 0, 1, 2, 3, 4, and 5, 6, 7 rubber bands. And so, okay, it makes sense to do maybe 5 rubber bands, right? Because that's within the data. Maybe even 8, right? Maybe even 9. But to do 20 is kind of too far off from the data is, and so the least square regression line is kind of just really guessing at that point, and it doesn't really have, it doesn't have data to fit in. So for that reason, the prediction made in number 2 is more trustworthy than the prediction made in number 4, right? Let me just go, maybe copy these two, just paste that in here, turn this back to 5, just so I could have the code for the other stuff here. All right, so then number 5 is asking, what is the y-intercept of the equation of the regression line? What does it mean? So the y-intercept, let me use a highlighter, is this over here. So the y-intercept is 25.33 repeating. What does it mean? It means that at 0, when a Barbie has 0, when Barbie has 0 rubber bands, the distance traveled will be 25.33 repeating centimeters. Yeah, that's literally it. This is like horrible handwriting. Sorry about that. Anyway, what is the slope of the equation of the regression line? Well, the slope is, let's look at another highlight here, is this number over here, 7.4. All right, so it's 7.4638. That is the slope. And what that means is just that for each number of rubber bands, or for one rubber, or for at least like one number of rubber bands, or for one rubber band, um, predicted distance. So I probably should have added that up above. Predicted distance traveled will, or increases, it won't do it in the future, it already does, increases by 7.4638 centimeters. Yeah, and so let me actually, it probably says for one rubber band, so for each rubber band, the predicted distance traveled increases by that value. And then here I probably should say, let me just rewrite this because it's so bad. So it says, when, see, I can only write good when it's small. So when what was I saying again? The y-intercept. So when the number of rubber bands is 0, or when using 0 rubber bands, the predicted distance traveled is 25.33 centimeters. Okay, so that's that. And all right, that's pretty much it for today. So let me just reiterate this. So trust number 2. All right, so yeah, I think that's it for today. Um, yeah, and then if anything, like the big ideas to kind of summarize things, the equation for least squared regression line is y hat, so predicted y is equal to a plus bx, where, which one was which? I think this one was blue, and then this one was, orange was b, right? Yeah, okay. So where a is the y-intercept and where b is the slope, And this is pronounced as y hat or as predicted y. And then, yeah, that's pretty much it. And then for the residual, right, the residual is equal to a minus p. So a being your actual value and p being your predicted value or whatever you get for y hat. Okay. And what else? There's this term called I literally don't know how to spell it. Hold up. Extrapolation, something like that. Extrapolation, yes, totally. So extrapolation, and well, um, oh, let's look at the definition here. So in mathematics, extrapolation is a type of estimation beyond the original observation range of the value of a variable. Okay, that's just so complicated. The action of estimating or concluding something by assuming that existing trends will continue or a current method will remain applicable. The extension of a graph, curve, or range of values by inferring unknown values from the trends in the known data. Yeah. So because of extrapolation, the idea is, how would I say this? The farther away your value is, like your x value is, the less accurate your prediction will be. Because again, you would want to be within the range of your data, of your x values, right? So you don't want to be predicting like, okay, what is the distance traveled by the Barbie when she has 500 rubber bands like around her? Like your squared regression line is not going, it's probably not going to give you an accurate result because that is so far away from the range within your data. And I can't put that to words for some reason. I can't put that in words, like I guess in writing. Um, so I guess the idea, to sum it up, how would I sum it up? Um, I guess it's just a rule. Just go with the rule. If the value x is too far away from the, or too far away in the x-axis, or from the range of the data, then the least squared regression line, which is this over here, will probably not give you the most accurate results. Okay. So that's kind of the idea behind that. So, um, I guess another way to sum that up is trust more the values that you get when they're within the range of your data, right? So 5 rubber bands versus 500 rubber bands, you can trust the result of five, the predicted distance traveled of Barbies with 5 rubber bands, then you can trust the result of the predicted distance traveled with by a Barbie with 500 rubber bands, right? Because in the data you only have up to 7 rubber bands. So yeah, I believe that's pretty much the three things that I covered, and then obviously, slope and y-intercept is just common sense. Like slope just increases, and the y-intercept is when x is 0, right? So when your value is 0, this is what you get. Your y-intercept is what it is. And then the slope is just it's like it increases your x value, by that number. And yeah, that's it for today. It was good. It was good. I'm gonna go now. Bye.